Hello everyone, welcome to the video lecture series of data structure. Our today's topic is Introduction to Data Structure. Hi, myself Janisha, your instructor. So let's start with introduction. See, the first our outlines are that what do we mean by data structure? Then we will see that the concept understanding of data structure and types of data structure. So let's begin with what do we mean by data structure. Some of you may say that, sir, data and structure means it might be data plus structure, because we already have such type of habit that usually we just divide the word into different words like data and structure. Okay. If I ask some other students, then they may say that, sir, it means like structured data. Okay, it might be possible. Another way, if I'm asking more and more students, then they may say like this, sir, data structure means easy processing of data. Okay, and some of my students answer me like arrangement of data. Okay, so right now it is not clear in our mind that what do you mean by data structure. It might be arrangement of data, processing of data, or structured data. What is that actually? Let's see with one example. Okay, see, first I am taking here one example of messy wardrobe. Just imagine a situation in your home that your wardrobe is not properly arranged. Then early morning, if you are getting late for your college, then what happened? You are just shouting on your mother that, mom, can you please bring me, where is my wallet? Where is my keys? Where is my purse? Such type of things happen at your home, right or wrong? Yes. Just because of a wardrobe is not properly arranged, you are not able to find out your clothes. You're not able to find out your perfect dress or matching earrings or anything else. So, what's the solution? Let's see. Here, see, this lady has perfectly arranged her wardrobe. She is just putting her purse in a particular place in wardrobe. Now, what happens? Whenever she come back again or open the wardrobe, she can easily find out her things. That's a importance of arrangement of things at your home. Same concept, same thing will happen with the data. If you arrange your data properly, then it can easily fetched out. Okay, if you store the data in a proper manner, then whenever you need the data, you can easily get it from your memory, right? That's the use of data structure. Now let's go to the definition of data structure. So in general terms, or according to your book or reference book, the definition is that data structure is nothing but it is a mathematical representation of data. Again, it's a mathematical model to represent data in the memory. Students, if you are arranging data in sequential manner, just taking an example, if in your class of 50 or 60, if I am arranging students like 1, 2, 3, 4, 5, 6 up to 10 in particular row, okay, then again I am arranging another students up to 11 to 20 in another row, then what happens? If I want to find or call roll number 5, then I know that roll number 5 should be at first row, roll number 15 should be at second row, because only 10 students are there in one row. So such type of mathematical calculation is going on in my mind, and I can easily fetch it out. I can easily call them. Okay, that's the usage of data. If you arrange your data properly in the memory, then you can easily fetch out. Okay, so here you can see the definitions of data structure. The first one is the mathematical or logical model to arrangement of data in a memory, or we can say that data structure is the portion of the memory that are allotted for a model in which the required data can be arranged in a proper fashion. So let's move forward. See, the next is types of data structure. So how many types of data structure? Here is a hierarchy of data structure. Students, you can see that data structure is divided into two different parts. Okay, one is primitive, another one is non-primitive data structure. The primitive data structure means what? If you studied C programming, then you might be aware about the primitive data types. Can you tell me how many primitive data types are there? Integer, float, character. right? Okay, so this integer, float and character can also known as primitive data structure. Okay, I'm repeating this sentence again, that the primitive data structure, it means, students, you might be aware about integer, float and character in your C programming, right? So integer, float and character, these data types are known as primitive data structure. So what do you mean by the non-primitive? Okay, before that, let me tell you that non-primitive data structure means the data structure which are not directly operated by machine level instructions. Suppose students, if you write like integer a, right, I am repeating integer a, then computer can easily understand that a variable consumes 2 bytes in the memory. If it is float, then it might be consumes 4 bytes in the memory. So integer and float, when you're declaring such type of things, it can directly understand by the machine level instructions. So such type of data structures are known as primitive data structure. And for the non-primitive, that means which are not directly operated by machine level instructions. Students, here the non-primitive data structure is further divided by into two different data structures. One is linear and second one is non-linear. Linear means in which we store the elements in sequential manner. The examples of linear data structures are array, stack, queue, linked list. And the example of non-linear data structures are tree and graph. So let's further discuss about the more about the primitive, non-primitive, linear and non-linear now. See, here the first thing we need to understand that what do we mean by the primitive data structure. See, here the primitive data structure means the data structure which is directly operated by machine level instructions. Okay, I have already told you that integer, float and character, these such type of data types are known as primitive data structure. Now, what do you mean by non-primitive, sir? Let's see. Here, the non-primitive data structure, it means that data structure which is does not operated by machine level instruction, right? So the types of non-primitives are linear and non-linear. Okay, linear data structures like array, stack, queue, linked list. In non-linear, we'll get tree and graph. Okay, so let's move further. See, here the thing is difference between linear and non-linear data structure, or right now we are just understanding that what do we mean by linear and non-linear. Just imagine a situation in class. If I arrange students in a proper fashion, like 1 after 2, then 3, then 4, in a sequential manner, such type of things is can say as linear arrangement of data. So students, linear data structure means the data structure which shows the relationship of adjacency. Okay, so this is a new word for us. That what do you mean by the relationship of adjacency? Students, if you are taking 1, 2 and 3, then for 2, 1 and 3 are known as adjacent neighbors. Okay, adjacent neighbors. So if the relationship of adjacency is shown in a sequential manner, then we can say it as a linear data structure. So we can say that if our data element has only one predecessor and one successor, then that data structure is known as linear data structure. Now, sir, these again two words are very new for us. Sir, what do you mean by predecessor and what do you mean by successor? The number like 1, 2, 3 in sequence of 1, 2 and 3, 1 is known as predecessor of 2 and 3 is known as successor of 2. I am again repeating this, students. In sequence of 1, 2 and 3, 1 is known as predecessor of 2 and 3 is known as successor of 2. Now you can easily understand, if your data member has only one predecessor and one successor, then this data structure is known as linear data structure. Fine. Now let's move on it. Like the examples of linear data structure are array, stack, queue and linked list. Okay, now let's go forward toward the non-linear data structure. Non-linear data structure is totally reverse of linear data structure, right? In this, there is no type relationship of adjacency between elements. Okay, students, if you are just imaging a situation where the data elements are connected with each other in random fashion, then the data structure is known as non-linear data structure. Let's go for the examples. The examples of non-linear data structures are tree and graph. Now let's start with the topic array. Okay, so what do we mean by the array? I think you already know in your C programming subject that, sir, what do you mean by the array? Array is nothing but a collection of homogeneous elements. Okay, it might be possible that sometimes you may ask me, sir, what do we mean by homogeneous elements? Okay, students, homogeneous means where each and every element contains same data type. If I am a human, you are a human, then we both contains the same data type as human. Then these data are known as homogeneous data, right? So array is nothing but is a collection of homogeneous data types. Okay, in array, students, the index starts from 0, and here we can see that array index starts from 0. In memory address in array, elements are stored in a sequential manner. If you can see this figure, here elements like 10, 20, 30, 40 and 50. My index starts from 0, 1, 2, 3 and 4. See, if my array size is 5, then the range of index should be 0 to 4. If my array size is 10, then range of my indexes should be 0 to 9. Okay, make sure about it. So here you can see the base address. Students, what do we mean with the base address? Base address means the address of the first element of array. Here you can see that 1000, 1002, 1004, 1006, 1008. The difference between two memory addresses are 2 bytes. So why it is 2 bytes? Because it's an integer type of array, right? In integer type of array, each and every element contains 2 bytes in the memory. That's why the difference between such elements are 2 bytes. So here our first element is 10. First element is 10 and its address is 1000. So we can easily say that the base address is 1000. Okay, now let's move ahead for the next topic. Our next data structure is stack. Okay, now just wait. Just imagine that in your childhood you might play a game like you have one rod and you are just put up your rings one above and above and above and above. Okay, such type of things is known as stack. Again, if I am taking a disk number 10 above, I am just putting another disk number 20, number 30, number 40, number 50. Such type of data structure is known as stack. Now let me tell you about the definition of stack. See, stack is a linear data structure. Again, stack is a linear data structure in which insertion and deletion, insertion of a new element or deletion of a new element can occur at only one end. Again, students, stack is a linear data structure in which insertion of a new element or deletion of the element can occur at only one end, and that end is known as top of the stack. Okay, so stack is nothing, it's a linear data structure where we have insertion and deletion operation performed at only one end. That end is known as top of the stack. Okay, fine. Now to what is top? Top is a pointer. Top is a pointer which can point to the always topmost element of the stack. If I am taking, just take a one box, okay, just inserting 10, 20, 30, 40 and 50. Again I am taking one box and I am inserting 10, 20, 30, 40 and 50. Now we have only one and to insert or remove our elements. Such type of thing is known as stack. Let me explain you with one figure. See, here in this figure you can see that the disks are coming up on each other like 80, 50, 60, 90, 100. Such type of arrangement of data is known as stack because you have only one end. Okay, in 20, 30, 40, 50 you have only one end to insert something or to remove something. Such type of arrangement is known as stack. Students, insertion operation in stack is known as push operation and deletion operation in stack is known as pop operation. Okay, see, this is another figure of stack. Okay, here the elements are there stored. The first shows that stack is empty. Then if we insert 10, then top pointer is pointing at 10. If we insert 20, then top pointer is pointing to 20. Okay, such type of data arrangement is known as stack. Now let's move forward for the queue. Okay, see, the next data structure is queue. So what do you mean by queue? Many of you are just standing in a queue of movie tickets. Okay, then what happens if I'm also with you standing in a queue of movie ticket? Then if I'm the first in the queue, then I'm taking the ticket from the ticketer, then just go out from the queue. Another person come, then he just take the ticket and move out from the queue. Once again take the ticket, go out from the queue. So it means that if you are the first in the queue, if you are the first in the queue, you are the person that should go first out from the queue. That's why the queue follows FIFO manner. It means first in, first out manner. Okay, so again students, queue is nothing but it's a linear data structure. So queue is a linear data structure in which insertion and deletion occurs at both ends. For insertion we are using rear end, and for deletion we are using front end. Okay, fine. So here are the some types of queue. First is a simple queue. Next is a circular queue. The third type of queue is big queue, and next is a priority queue. Okay, so here you can see the example of queue. See, in this figure you can see some of people are going further in the line. Okay, well, the first person will get the ticket and go out from the queue first. Here is another example of queue. You can see that the next is this green shaded or black shaded queue is known as simple queue, and this yellow shaded queue is known as circular queue. Here you can see the two different pointers are there. The first pointer is known as rear and another pointer is known as front. Rear is used for the insertion purpose and front is used for the deletion purpose. Now let's go ahead. So here you can see the linked list. What do we mean by the linked list? Students, linked list is a collection of nodes where each and every node contains two different things. I'm again repeating this sentence, that linked list is a collection of nodes where each and every node contains two different things. One is data and second one is a pointer. Okay, so nodes of the linked list are not the contained in the continuous memory. See, it is not like array. It is not like array that if your address of the first element is 1000, then second must be at 1002, third must be at 1004. No, it's not like that. In linked list, if your first node, address of the first node is 1000, then second might be 200, third might be 500. Okay, so these things might be possible. So now let's see the types of linked list. The first type of linked list is single linked list. Single linked list, it means that when you're the last node of the list point to the null, last node of the list pointing to the null, then that linked list is known as single linked list. See, here you can see in the figure the first node is pointing by the first or start. So students, in linked list we have first pointer. First is a pointer which pointing to the first node of the list. Okay, so the boxes are known as nodes where each and every node is connected with each other like train compartments. If you know about the train compartments, the train compartment is known as our node and the link between two compartments is known as pointer. Fine. So in node we have two different things. One is data, one is pointer. Okay, so that concept is known as linked list. So the next of this circular linked list. In circular linked list, students, the link of the last node is pointing to the first node of the list. Fine. So next is doubly linked list. In doubly linked list, the node contains two different pointers. If you are just imaging me as a data or node, then this is my left pointer, this is my right pointer. So here these both pointers are known as doubly linked list nodes. Fine. So here in today's lecture, students, we learned what do we mean by the data structure, types of data structure like linear, non-linear. Then we have seen that, sir, what do we mean by stack, queue, and now linked list. For the rest of the part we will see in next lecture. So if you have any doubt, then please feel free to ask me. Thank you.